Okay, solving equations with radicals. Solving equations, this assignment's actually pretty easy. Before you solve an equation as normal, you should always list out how many answers at least you think you're trying to find. Like we learned from the other assignment, it's not always that much, but at least it gives you some idea. Now, whenever I have just x inside a square root, there's only going to be one answer. I can guarantee that. Okay? Guaranteed. Here's a way to do that. You want to kind of deal with this like you do a parent. When you have a parentheses and then outside that parentheses is a second power, you're going to use q. Okay? So you're going to replace x plus 2 with q, but there's a few things. You have q is in a square root, and then you need 3 outside, and then equals 6. Okay, then what you do is you divide by the 3, okay? Because it's like 3q, okay? 3 square root q. You divide by 3. So the square root of q equals 2. Now, how do you get rid of a square root? All you do to get rid of a square root is you take both sides to the second power. So q, and also I'm not using any kind of root here, so you don't do a plus minus. You don't worry about that. It's just 4. Okay, so now bring in the x plus 2 expression. Now you can find your one answer. So minus 2, x equals 2. Okay, my next problem. There's only one x inside of the radical. So we're going to replace this expression with q, and we got a square root, and then a plus 2 equals 2. Okay, well, the first thing I need to do is get rid of the plus 2 outside of here. So I collect non-q's over here. So that's 0. Now to get rid of your square root, you just take both sides to the second power. So I have q, and 0 to the second power is still 0. Now I bring in the 2x minus 3 plus 3 plus 3, 2x equals 3. So it's 3 over 2, or 1.5. Okay, so these don't take a long time to solve, really. Again, you just have x inside of a square root. There's one answer. Okay, so we need to bring in q with a square root. We have a multiplier of 5, and then it's just equal to 15. So we divide by 5, so we got the square root of q equals 3. Now I need to take both sides to the second power so that the square root eliminates. Okay, and 3 to the second is 9. Okay, now bring in your 3x. Now divide by 3, and 9 divided by 3 is 3. If you think bringing in the q's pointless and you think, well, I just divide by 5, second power, and divide by 3, go for it. Okay, just you better get the right answer. Okay, there's one answer here. Now you got a little problem here. You have this minus, so you need to put a plus negative, and you need a multiplier of 1, okay, on that. Okay, so first I've got q. It's in a square root. It has a multiplier of negative 1, and then we have a plus 7 right there. Okay, so the first thing I do is, first we got to deal with the 7, okay? Before I deal with my multiplier of negative 1, I need to eliminate the 7 first. So I need to minus 7, minus 7. So that equals negative 13, and now I have negative 1. Then the square root of q. So negative 1 is a multiplying coefficient, so to deal with that, you're going to divide by negative 1. And the square root of q equals positive 13. Now I take both sides to the second power, and then I get q. And then 13 to the second power is 169. Now, bring back your x minus 4. Now you solve. So plus 4 plus 4. So 169 plus 4 is 173. Again, if you put 173 in for x and subtract 4, that's 169, but the square root of 169 is 13. Well, 13 times negative 1 is negative 13, but if I add a 7 to that, it's negative 6. All checks out in the end. Okay, this time, if you can't see that, it's not a square root, it's a cubed root. There's a little subscript 3 there. Alright, so you're going to do the same thing, but q's in a root, and then it's a cubed root. Equals 5. Okay, well, there's nothing really I have to deal with. I don't have a multiplier. I don't have anything outside being added or subtracted, so I just go ahead and get rid of the cubed root. Now, if you get rid of a square root with a second power, you're probably going to get rid of a cubed root by taking both sides to the third power. Okay? So 5 to the third equals 125. And by the way, there's one answer. Now I bring in my 2x plus 7. So I minus 7, so 2 times x equals 118. Then I divide by 2, and I get 59. Okay, my next problem, there's only an x inside of a root, so we're good. Okay, remember, I'm gonna actually bring in q for that. You really don't have to. If you want to do these without bringing in q, go for it. So it's under a cubed root, has a multiplier of 4, and then it has a 2 being added. Okay, so I'm minus 2. So I have 4 times the cubed root of q, and then negative 2. Okay, now we're done adding and subtracting. Now we got to get rid of the multiplier, and then we divide. Okay, negative 2 divided by 4 is negative 0.5. So I've got the cubed root of q. Now to cancel out a cubed root, we're going to take both sides to the power of 3. Now on your calculator, you got to remember if your base is negative, please parenthesize that, and that's going to be negative 0.125. Okay, now here all I had was x, so essentially q is the same as x, so I don't even need to do anything. There's my answer. Okay, next problem. So I'm going to replace that expression with q. It has a root. It's a cubed root. It has a multiplier of negative 2. It has 7 being added outside. Okay, so first we got to take care of the number that's being added or subtracted. In this case, it's 7. So I'm going to minus 7. So it's 8. So now I've got negative 2 times the cubed root of q. Now we got to take care of our multiplier of negative 2. I cancel that out by dividing. Negative 4. And then I have the cubed root of q. Okay, now to cancel out the cubed root, we take both sides to the third power. Once again, if you have a negative base, you need to actually parenthesize that in the calculator. And I got negative 64. Okay, now bring in the original expression, which is 2 times x plus 5 equals negative 64. Then I keep working, minus 5 minus 5. So 2x equals negative 69, and then I divide by 2. And that's going to give me negative 34.5. Okay, and then the next one answer. Q cubed root has a multiplier of 3, a 2 being subtracted. Now we can go from there. First off, we take care of the number that's being subtracted. We're going to add. So it gives me negative 2. 3 times the cubed root of q. Okay, so we take care of the multiplier of 3. We're just going to divide by 3. So we got the cubed root of q. I'm just actually going to leave that negative 2/3 because I'm going to get rid of my cube by cubing it, I should say, because those cancel. Then I go negative 2, ABC 3, and I'm just going to take that to the third power. That's going to be negative 8 over 27. Now, if I go look at the original expression, it was just an x. So when I have q, I essentially have my answer, because x and q are the same thing. So negative 8 over 27. Again, if you don't want to use the q, it's possible to get through on these without. It's not a problem.